All right, we'll have a frictionless surface, and we've got a cannon that's moving. I'll just use a box. All right, we have a cannon that's moving at 2 meters per second north. I'm going to have this way be north. And then at some other time, it's going to shoot the cannonball out. So it shoots the cannonball out really fast. The cannonball is going at 32 meters per second. But it puts the cannon to rest. So if it was not moving in the first place, if the cannon started at rest in the first place, it shot the cannonball out. It would have made the cannon slide backwards, but since it was already moving forward, it shoots out the cannonball. There's a reaction force, and it's able to bring that to rest. So we're asked to determine the ratio of masses between the cannon itself and the cannonball. So I'm going to call capital M the mass of the cannon, and I'll call lowercase m the mass of the cannonball. And when they were together, the mass would be m plus m. So that's how I'll analyze the situation. So I'm going to say momentum. I'll just say the total momentum before the cannonball gets shot out has to equal the total momentum after the cannonball gets shot out. That's the conservation of momentum. So the momentum before they got shot out would be mass times velocity, but it's the total mass because both the cannon and the cannonball are moving together at 2 meters per second. I'll just put 2. Meanwhile, after the cannonball gets shot out, I think I have to split this up in, well, actually, yeah, I mean, the total momentum will be the momentum of A, the cannon, prime, plus the momentum of B, the cannonball, prime. However, the cannon has now come to a rest, so that's nice for us. I can cross out the momentum of the cannon. All the momentum now belongs to the cannonball. So this will be m plus m at 2 meters per second equals the cannonball by itself is just lowercase m traveling at 32 meters per second north. Everything's with respect to north right now. So the goal is to find the ratio of the masses, and a couple of you did that for an earlier problem set, so you know what that means. Some of you might not know what it means. It means I want you to find m over m, or the reciprocal, one or the other. Find out how many times heavier the cannon is compared to the cannonball. We won't know the specific masses in kilograms, but we can know we can know the ratio. So this equation I have here, I want to try to rearrange it to the form of m divided by m. So to do that, I'm going to start with the distributive property on the left side. So that gives me 2 capital M plus 2 lowercase m. And on the right side, I have 32 lowercase m. I'm going to collect all the lowercase m's to the right side. So subtract it. So that leaves me with 2 capital M's on the left, and 32 minus 2 gives me 30 lowercase m's on the right. Now, I need to rearrange this to look like m over m, and that's accomplished by dividing both sides by lowercase m. as well, dividing both sides by 2. So 30 divided by 2 is 15. So that's the answer. What this is saying is that the cannon itself is 15 times the mass of the cannonball. Or if we ended up solving for the reciprocal, we would have got that the cannonball is 1/15 the mass of the cannon.